Hi, my name is Tuturi. I am a data scientist. So far, we discussed types of machine learning algorithms, linear regression, logistic regression, which uses binary values yes or no, and linear regression, which uses the linear data and fits the best fit line between the outcome dependent variable and the independent variables. Logistic regression is for the probability of winning the chances of winning an event logistic and gives a logic values yes or no kind of outcomes dependent classifications we can get used for logistic regression. And decision trees is again it's a we discussed for it can use for regression as well as classification. And random forest it's a forest is a group of decision trees combined to form a forest and gives a better predictive values. It uses for both classification and regression. Okay, and we discussed on the gradient boosting technique algorithm, which uses the boosting technique, which is used for the it combines all the weak predictions, weak learning predictions, and to form and combine together to form a better accuracy, giving a better model. Okay, so these are we discussed, and these supervised machine. These are all the supervised machine learning models, and they process the text um, data and label the data basically, and gives the prediction values. Today we are going to discuss on the much more advanced. Which basically takes not only text data, which also process the image processing or uh, speech recognition models. So the image processing, we can say the CNN models is it's better used for image processing, and RNN it used for speech recognition or predicting of machine translating models. Or, this is RNNs, and the more advanced is LSTM, long short term memory methods. So these are all the advanced neural networks, models, we can say. So we are going to discuss how these neural networks models, CNN, RNN, LSTM today. Before discussing those neural networks algorithms, we'll start with the neural. What is meant by neural network? Neural network is similar to the architecture and the design of a neural network is similar to the human brain. How it works, a human brain works. It uses the similar structure of neural system in a human being. So that is a fundamental the building block of neural system is the neuron. So the similar kind of neuron will take in the machine learning concept. So it takes what neuron takes is it takes a number of inputs and it process and gives an output. So that's a the input number of inputs it takes and process and then gives an output. So that's a neuron simply. So the similar functionality will be taken in the machine learning neuron also. So the number of neurons it takes and it process all the each neuron it takes the information from different inputs and it process the output. So and the layers, the number of layers is will be connected from different neurons, and it passes from one layer to the other layer. So that's how the neural network is. So the layers are from one layer to passes the information to the other layer, and then finally it gives to the output. So they from input layer to the output layer, there are the number of hidden layers will be there. So the hidden layers will be will be how many number of hidden layers when the network the model will be taken is called a deep learning, deep neural networks. So that's depends on if we only take only one layer, that is single layer hidden layer neural network, and it is deep learning, the number of hidden layers will be increased. So in the deep learning, so that's a deep neural network things. So now let's take the CNN model. It was invented in way back in 1960s. Okay, and we are using it's basically we are using for image processing data to process image to find out if what is a dog or what is a cat. So two different, the dog is dog and cat is cat. So we need to train the model. Okay, so we need to train the model with the dogs and dog images and the cat images, and we train it and gives the model image processing model CNN. It takes that and gives the output. It processes that and gives the this is image cat and this is dog. So that's image processing data. We generally use for CNNs, and how it works is CNN have it has different layers: the convocation layer and the convolution layer and the pooling layer and the fully connected layer and the normalized layer and output. So it gives output. So these are the number of layers it has in CNN convolution neural network model. So that's it processes the image and it gives the output. So the CNN where it can if we find out where if a person is a criminal with a criminal background is passing through an airport or something, and we need to find out this is the to find out this is the person, the image, take the image of the person, and it predicts whether this guy is a criminal or not. So that's in that kind of applications, policing or the criminal records verifications, that kind of applications, that's it's very useful in CNN. So basically it's image processing, or the speed, the self-driving cars. If we want to apply there, we need to feed all the training data of the images. What is the straight road or left road or right road? All these images we gave to the our model, and then it predicts, and then we test it. What is the left and what is right, what is the straight road. So it identifies. To those images we need to give to this our model for training, and then it gives the predictions will be, and depending on that it predicts. So CNN model will be used for mostly on images. It not only image processing, that it also works on the text. So it the if we are taking the convolution one dimension. So it's a signal, or the text data, or signal data. So, or a two dimensional, it's image data, the photos. If it is three dimensional, it's a, video visualization, videos data. So we can work on this. We can use the CNN model in a much better to build all this. Basically, it is very good, suitable for the image processing systems to predict the image processing. That is where we are very much used in CNN, and it's very till now it's very good in finding image processing, computer vision model. We can say that. The next model we are going to discuss the RNN. RNN is the name itself is a recurrent neural network, in the sense, unlike the CNN, it also processes the sequential data. The RNN can. The RNN is the recurrent. It takes the input layer and process it, and it passes through the other layer. Okay, and it stores the memory and the memory information, memorize the previous layer. It passes it stores that information, and it processes again and then gives to the other layer. So that's a recurrent. It basically say recurrent neural network system. So it takes the input, process it, and process it and pass it to the next layer, and also memorize it stores it memorize the information, and keeps the memory for a short time, and then it gives to the other layer. So that's, and keeps on works on that. So that's a recurrent neural network system, and the number of layers it will be having is the one to many, one to one layer, one to many layer, many to many layer, and many to one layer. These kind of layers will be there in recurrent neural network. Where we can use it, the RNNs can be used for now NLP. RNN is very useful in NLP, natural language processing, where we can predict what is predict the next sentence, next word is. For example, if we say, I'm studying graduation. I was joined last year, 2 years back, and I'm studying second year graduation, and I'll be completing my graduation. Then our model should predict the sentence that the next year I'm going to complete the graduation by next year. So it should predict that. So that predictions will be so, because it knows the system should know. The previous sentence was, I was joined 2 years back in the graduation, and this is second year, and third year, next will be the third year, and I'm going to complete my next year graduation next year. That's it should predict I'm going to complete next year. So rather than if the model predicts that this year, that's a wrong thing. It is wrong in the sense, it is the 3-year graduation will be completed this year. So that's the prediction is wrong. So it has to be. We need to train that. The model should work in that way. So that's RNN is used for that. So it stores the information in its memory and then it passes to predict the values next. So that's RNN. So the layers were discussed, and RNN is used for NLP, machine translation, or the speech recognition applications, or the as we discussed now, the predictions of in the text predictions next. For example, Google auto check is or the uh, uh, is one of the good applications. We can say Google Assistant, Alexa is one of the very good example for Anand or Google auto checker or auto. So those are the applications for RNN. We can say. Now the third is LSTM, long short term memory algorithms. LSTM. It is similar to the RNN. It's more advanced than RNN, but it is it's RNN. The it also it's stores. It has also has I mean it stores, it processes it memorizes the previous layers and passes. It also has it is having the nodes of cell node, input node, output node, and there is also a node called forget node. And the forget node, the cell node is it stores the information what were the information of the in the cell, and it processes the input node, it processes the input and it gives the output. The forget node is after processing after some time we need to the cell the information to we need to forget it, because if we keep on store the information it leads to overfitting in the sense, and it gives the training results might be it gives the it impacts on the accuracy. So we need to forget the information, so that's the forget get will do that information. So that LSTM is much more advanced than RNN. So that RNN sometimes it leads to the overfitting, but LSTM is address that application that issue, overfitting issue. So LSTM will have the cell, the information will be stored, and input get process the input information, and output get it gives the output predictions, and forget get it forgets the information which is not required. So that those are the layers in LSTM, and it's used for machine translation and speech very good speech recognition. There we can apply for LSTM. So those are all the neural network algorithms, CNN, RNN, and LSTM. These are the very good neural network examples for neural networks. So that's all from today. If you like this video, please like it and share it. Thank you very much.